Hello. So I've just given you instruction on what you're going to be doing. So hopefully now you will actually be able to watch this video in Edpuzzle. Today we're watching this during class, but you will actually be watching the video for 5-2 before you come into class on Monday for my B-Day students and on Tuesday for my A-Day students. We're starting today in 5-1, which is nth roots and real roots and all that kind of stuff. So I want to kind of review our exponent rules really quickly. Let me erase. I was practicing earlier. You like that? Draw eraser. Large eraser. Where's it at? Oh, there we go. Okay, so if you will recall, our exponent rules tell us that if we have x raised to a power, that means that we have x times x. Or if we have a number, raised to a power, that means we are multiplying that number, the number of times our exponent represents. So if, and then we had the power rules. So if we had x squared times x cubed, then that was the same as adding those exponents. So we would get x to the 5th. And if we had x squared cubed, then that meant that we were taking x squared and multiplying it out that number of times, right? So there were 3x squareds, which gives us x to the 6th. So we multiply these. So this would be x to the 2 times 3, which is x to the 6th. Also, anything to the first power is just that number. And anything to the 0 power is 1. So we kind of reviewed all this when we were talking about polynomials, but I wanted to give you guys another quick review before we started talking about the reverse of using exponents. And that is using roots. Now, you guys have seen this expression numerous times, and all it means is when there's nothing here, we call it, that's an empty space, so it's not a 0, it's an empty space. Then we know that that's just asking us for the square root. And we've talked about how the square root of x squared is just x, or the square root of 4 squared is just 4, but that the square root of 4 is 2, because when we take 4, when we draw our factor tree, we have a pair of 2's, which means that that square root is then 2. So I hope that was a nice little review. If not, you can go back and watch just this section again. Now let's go to your notes packet, and we're going to talk about example 1 here. This says, we're going to fill in our blanks. I'm going to zoom in so it's a little bit easier to see. And we're going to fill this in. Now I'm going to put filled in copies of your notes onto Canvas so that you can see them there as well, just in case you need to look at them. But we'll just start here for now. So this says, we're going to talk about how exponents and radicals are used to talk about real numbers. So we're filling this blank first, and it says an nth root of a number c is x such that x to the n equals c. Okay, so that nth root we're looking at is our exponent when we're looking at x. An nth root can be denoted by a radical symbol with an index, call it the index, of n. So we have the nth root of c, it looks like that, and c is called the radicand. Okay, so if the index is not written, it's assumed to be a 2. So we talked about square roots. So if you see that with nothing in there, it's just a square root. Okay. Now let's fill this in. So we put in here, and again, remember that's called the index. We put our big C here. I'm going to call that our radicand. Just that piece. And the whole thing is called a radical. Okay. Two rules that you kind of need to know is that if you are looking for even roots, so this means that our index is an even number, then they're going to come in pairs so that there's an even number of roots. And those pairs are always going to be opposites. Now, a lot of this might not make a whole lot of sense right now. And this is the point in a regular lesson when you guys would all stop me and be like, what do you mean? What do you mean? What do you mean? And this is the point in the lesson when I'll tell you, just stay with me till the end. But now I don't have to do that. I don't have to stop and pause. So we're going to keep going. Odd roots are going to have an odd number of real roots. And we should talk about, when we're talking about radicals and things like this, we're really looking at real roots more than anything else. Because for all intents and purposes now, we're kind of past the imaginary stuff. Imaginary roots are important when we're talking about polynomials, like we did right before Christmas. But now we're talking about real roots and finding real roots of real numbers. So odd roots have an odd number of real roots. And these, you can take an odd root of a negative number. You cannot take an odd root of an even. A negative root of an even index. Okay. All right. So now I'm going to go back into Pearson and we're going to do this like we do in the classroom. So here's our first example. And I'm going to pull up my writing tool here. Got a lot more options. So this says all of the real cube roots of 125. Now, this is a cube root. Oh, it's going to work for me. There we go. Let's erase it. Sorry. We get to play along here for a minute. Okay. Cube roots of 125. So a cube, you know, means 3. So when you have a cube root, you're going to look for triples in your factor tree. So if we start, oh, it's not going to work. Okay, well, good news. I have a backup plan. Let's go back to our OneNote. And here we have the cube roots of 125. I'm going to move this down, though, so that you can see my actual writing. So we're going to take 125 and we're going to put it in a factor tree. Now we know that because it ends in 5, we can take a 5 out. We get 25. And then when we factor that, we get 2 more 5s. So now I want you to notice that we have 1, 2, 3 5s there, correct? So if there are 3 5s and we're looking for a cube root, cube means 3, then 5 is our cube root of 125. Now, if you look at, all right, so that is the first part of example 1.